Solar Thermal Power Utilization in Manufacturing Facilities by Cassidy, Dawson Jones, and Alan Mullican. Solar thermal power has emerged as a promising alternative for powering manufacturing plants, leveraging solar panels to generate electricity. By doing so, cost for utilities can be reduced through this method, as well as creating a cleaner energy source for future generations. A complete changeover to this method may take some time due to the technological limitations of today, such as the continued development of solar panels as well as other sources of energy. This paper aims to provide an understanding of how solar panels work and the benefits and current challenges of current solar panel technology in manufacturing environments. Solar power generation in manufacturing relies on concentrating sunlight with reflectors and receivers. Reflectors direct sunlight to receivers, heating a transfer fluid to produce steam for electricity. Some systems use tracking controls to optimize solar panel positioning. Controls include single-axis and dual-axis trackers, adding complexity. Tracking involves various drivers, software, and physics. While these systems offer benefits, challenges persist, including technological complexity and potential drawbacks. Solar energy presents numerous advantages for manufacturing environments, primarily reducing energy losses and enhancing efficiency, thereby proving cost-effective. The directed concentration of sunlight towards thermal needs at the required temperature minimizes reliance on intermittent materials and processes. Another significant advantage is the environmental cleanliness of solar energy production. Harnessing the sun's natural power eliminates the need for external fuel types, with its historical roots tracing back to 7th century BC, when early humans ingeniously used magnifying glasses to create solar power. Financially, the use of solar power offers a considerable advantage through a reduction in electric bills over time. Despite the initial hefty investment, the long-term savings make solar power a wise and economically sustainable choice. Furthermore, the cost-effectiveness extends to lower maintenance expenses associated with manufacturing facilities. The shift to solar energy results in decreased machine maintenance, as machines no longer rely on non-renewable fuels for regular operation, contributing to substantial overall cost reductions. Arguably one of the most advantageous aspects of solar energy in manufacturing is its reliance on the abundance of sunlight. While the sun may not shine 24 hours a day, the periods of sunlight during operational hours are sufficient for extensive energy storage. Leveraging the sun's infinite energy source allows manufacturing facilities to tap into a sustainable and continuous reservoir of power, ensuring consistent energy supply and positioning solar energy as a reliable solution for manufacturing operations. The adoption of solar power in manufacturing environments, while advantageous, comes with certain setbacks that warrant consideration. One significant drawback is the substantial upfront costs associated with the installation of solar panels. This encompasses not only the acquisition and installation of the panels themselves but also includes the integration of essential equipment such as inverters, batteries, and wiring. The financial commitment required for these technologies often gives pause to plant managers and companies, leading to hesitation in transitioning from conventional power sources to solar. Moreover, the planning and configuration of the plant's roof layout become critical considerations during the installation process. Plant managers must strategically lay out the solar panels to maximize energy collection, further complicating the decision-making process and necessitating adjustments to accommodate the new solar power infrastructure. This spatial requirement is particularly relevant as most manufacturing processes demand a substantial amount of power, which, in turn, necessitates a larger number of solar panels. Another pertinent issue revolves around the inherent dependency of solar power on sunlight. While solar panels are highly effective when exposed to direct sunlight, their efficiency diminishes during evenings, rainy days, or cloudy conditions. This dependency poses a challenge to the consistency of energy generation, potentially disrupting manufacturing processes during periods of reduced solar energy collection. In essence, the decision to incorporate solar power in manufacturing involves navigating these challenges, understanding the financial commitments, spatial considerations, and the impact of sunlight dependency on operational stability. Despite these drawbacks, the potential long-term benefits and sustainability of solar energy make it a subject of ongoing consideration and innovation within the manufacturing sector. In summary, solar panels represent advanced technology harnessing the sun's light to generate energy for diverse applications. While offering long-term benefits such as cost savings and environmental cleanliness, these systems come with significant challenges like high upfront costs, substantial space requirements, and dependence on weather conditions and sun positioning. Specific system specifications and locations introduce varying pros and cons, mitigated in part by technologies like tracking controls. The affordability of these systems, particularly for large industries, plays a crucial role, requiring a careful evaluation of upfront costs versus long-term gains. Despite the current challenges, ongoing research, both by government entities and individuals, holds promise for advancements in solar panels, tracking systems, power grids, and related technologies, indicating a substantial potential for growth in this field.